these couple problems here, okay, starting with question 6. And just so that you guys understand how these types of problems are going to be set up. Okay? So it says a flagpole casts a shadow that's 24 feet long. So if you assume you have your flagpole right here, okay, the shadow that's cast is 24 feet long. Okay, and then it says a flower standing nearby casts a shadow 3 feet long. So let's say you have a flower and its shadow is 3 feet long. Okay. So in looking at this, if you want to see how tall is the flower, well, each of these forms a right triangle. So because these both have right angles, and you assume if a shadow's cast, or if a shadow's being cast, that means the sun is on which side of my drawing, the left or the right? It's opposite the shadow, right? So the sun is over here, and the angle from the ground to the sun that passes through from the tip of the shadow through the tip of the objects that's casting that shadow is the same for both of these, right? Would it make sense that that's the case? And I'll kind of talk about this here in just a moment. But you have these two similar triangles by AA similarity. And so you can now look to relate them. So it says that the flagpole is 12 feet tall. So we can label that piece as well. And so all we're looking for is the height of this flower. And so the equation that we can relate, or the proportion allows us to relate these, is we take our unknown, the height of the flower. That corresponds to the height of the flagpole, which is known as 12. And that's going to equal the ratio of the known pieces that correspond. So we know the shadow of the flower over the shadow of the flagpole. And so this gives us the ratio that we're looking for. And now we simply need to solve this. In order to solve it, we multiply both sides by 12. That's going to cancel the 12 from the left side, leaving h is equal to, and then just reduce. 12 goes into 24 2 times, and so you get 3/2 as your answer for that. Okay, so you are going to look, this is very similar to the types of questions that you'll see involving setting up and using similar triangles. Okay, let's say we take the next example 7. Okay, it says Sam wants to enlarge a triangle with sides 3, 6, and 6. So let's say here is our triangle. So 3, 6, and 6. If the shortest side, so if he wants to enlarge this, the shortest side of the new triangle is now 13. Basically what that means is if you were to click on this and drag the corner, okay, everything stays proportional. The enlargement will be the same proportional triangle, but now it says that this new longest side is 13, or sorry, the new shortest side is 13. Okay, you still are going to have this isosceles triangle, and because we're enlarging a given triangle, we know they're going to be similar to each other. So this was just given as similar. And so we can set up our ratio. If we want to know this unknown side, which I can call x, we set up the ratio x is to its corresponding side, 6. As the two known corresponding pieces are, well, x is from the larger triangle, so we'll use the known base of that triangle compared to the known base of the smaller triangle. And now we were able to solve for x, once again, by putting our variable in the top left of our proportion. We simply need to multiply both sides by this denominator to isolate it. 3 goes into 6 twice. 2 times 13 gives us our answer of 26. Okay, let's take a look at our last sample problem here. Okay, this one says a 6-foot ladder leans against a building. So let's say we have our building here, and we have a 6-foot ladder. Okay, so here is the ladder leaning against the building. It says that it's 4 feet above the ground, so that means that this height right here will be 4 feet. Okay, and what it asks is, at what height would a 15-foot ladder reach if they formed the same angle with the ground? So in order to identify this, if we took a 15-foot ladder and it had this same angle right here with the ground, so that this angle was the same, we assume they both reach directly up that building. So again, by AA similarity, we have similar triangles here. We were told that this second ladder was a length of 15 feet. And we wanted to find what is this height of the ladder. So we can take our unknown height over the corresponding piece of the smaller triangle. The height of that smaller triangle was 4. Set it equal to the ratio that we know, the longest length 15 over the shorter length 6. And so once again, we simply solve for our h. And when we do, 2 goes into 4 twice, 2 goes into 6 3 times, 3 goes into 3 once, 3 goes into 15 5 times. And so you're left with h equals 5 times 2, or 10, for your answer. Okay, so in all of these cases, you're able to set up and solve using similar triangles. Are there questions regarding any of those?